Hello. So in this video, we're going to continue with the Pong tutorial, and we're going to get where the ball bounces off the paddle. So I'm going to define a new function then to handle, checking to see if the ball hit the paddle, and then kind of what happens then at that point. So I'm going to make a new function, and I'm just going to all right, so a function called ball versus paddle. Notice the camel case. I've actually used three words here, so lowercase b, uppercase v, and uppercase p. It's a very generic paddle, right? So I am going to have to find which paddle I'm talking about. Now I know at this point in the code I don't actually have more than one paddle, but thinking ahead, I'm going to use the same function for both of them. All right, so then I'm going to use an if statement because sometimes the ball hits the paddle and sometimes it doesn't. And I'm going to have to write some code in the parentheses of the if statement in the test to determine whether the ball has hit the paddle or not. So there are different ways this could be done. And I'm going to make things a little bit more simple. And as far as this collision detection goes, I'm going to pretend that the ball is a square. That just makes this collision detection a little bit easier. The way that we're setting up our game here, we don't need to worry so much about the corners, the edges of the circle as opposed to the top and the bottom and the left and the right. So we can get away pretty much with pretending like this ball is a square. So here is the code then for how to detect whether a rectangle and a rectangle are touching each other, whether there's been collision or not. And so it is, we're going to do the rectangle 1 and then rectangle 2. All right, so ball is going to be like rectangle 1 here. So if I say ball dot x, now I need to do ball dot position dot x. So I define paddle and ball a little bit differently. Plus the width, and so ball dot width is greater than or equal to the x of the paddle and, so I'm checking all the different edges that could be colliding with each other. So I'm going to have a lot of these and symbols here to check each of these components. All right, so the next part is whether the ball dot position dot x is less than or equal to the paddle dot x plus paddle dot width. And you can see my eyes going over to the other screen as I'm copying off this example. This is definitely not something I just had memorized. And there's 4 conditions we have to check. Whether the ball dot position dot y plus the ball dot height, which is the circle, so I've only defined as width, is greater than or equal to the paddle dot y. And you might have noticed what I did there. I need that basically be in this spot. I'm going to press enter. And the ball dot position dot y is less than or equal to paddle dot y. And so this is a rectangle versus rectangle collision. Again, I'm pretending like the ball is a rectangle, a square rectangle. And I probably didn't need to use exactly this formula. If you think about the way that the ball is going to hit the paddles, it might not even necessarily, we don't really need to figure out whether it hit it on the backside. But I'm just going to stick with this because this is a collision function in collision code that will be used over and over again in other games that we use. Right, so we have that there. So then I determine, okay, what happens? So if there is collision between the ball and the paddle, then I want to make the ball move in a different direction. So I'm going to take the ball velocity dot, and I know that I'm only going to make it bounce left and right. That the y stuff I'm not really messing with at this point. So it's only ball dot velocity dot x is equal to negative ball dot velocity dot x. All right, another thing that I could have done here is I could have said ball dot velocity dot x times equals -1. It would do the same thing. All right, so this should cause, that's at least the code to detect the collision and cause the ball to move in the opposite x direction. But it's a function that I have not called, so I need to call it. So same thing here. I'm going to call ball versus paddle. And I do need to provide which paddle I'm talking about, because that is what I promised in the function here. It would cause an error if I didn't also give it when I call the function. So we'll test it and see what happens. All right, so I did get it to bounce off. All right, if I change the velocity, the initial velocity of the ball a little bit, to not have so much of a y component. All right, I can see if I can get it to bounce. Yep. Now I did notice that it's almost like it bounces a little bit too early, and the speed is not very fast. So I don't think that that is really the case, that it can't respond quickly enough. So I'm going to take another look at my if statement here to see if I wrote something wrong, because it's not responding the way that I expect it to. All right, position.x is less than paddle.x plus paddle.width. Position plus, and I said ball.width, but that's because it's got the same things here. I think I know exactly what the issue is, though, because the ball draws from the center out. So this mixing the two ideas here does cause a little bit of an issue, because this code here is based on a shape being drawn from the top left corner over, just the same way that a rectangle is. So that's why I'm getting this to happen exactly the way it is. I do wonder if I just change the width kind of stuff on ball, if I just divide them by 2. Right, so anytime I mention the ball's size, certainly reducing it would make it better. The paddle I shouldn't have to bother with. So again, the reason I'm doing this is because circles draw in a different way that rectangles do, but I'm pretending like the ball is a rectangle. So let's see if this at least makes it better. All right, yeah, so I think that actually was the fix there, where instead of just saying ball.width, referring to the diameter of it, that it should more refer to the radius, because circles draw from the center out, which would be based on the radius of the circle. All right, so we got the ball to bounce off the paddle then.